to a stationary state. On the real channel. Hello, Doro. Hello, Transport Boy. Hello, everybody. Did you hear about the black hole that's bigger than the Milky Way? Hello, John Foster. Great kitty content lately. Seeing a lot of Baji and Suji. Thank you, Varun. Oh my gosh. Love it. Thank you so much. Baji's not behind me yet, but thank you so much for enjoying the content and liking and sharing and subscribing. Most kind of you, and thank you and welcome to the live. And please do like the live, and can we get 20 likes? So what would this final stage look like after a system has lost gravitational energy? One might suppose that it would depend on all the complex features of the star from which it had formed, not only its mass and rate of rotation, but also the different densities of various parts of the star and the complicated movements of the gases within the star. And if black holes were as varied as the objects that collapsed to form them, it might be very difficult to make any predictions about black holes in general. Oh, really? Oh, goodness. Oh, wow. That's amazing. I don't think I've heard too much about this black hole, but thank you for telling me. Imam, hello. Salam alaikum. How are you doing? It came across my news feed that a high schooler discovered it by accident. I watch Andre and Noah the cat streams almost every day. Thank you, Steven. Oh my gosh. How very nice of you. It wouldn't let me say commit crimes. Oh, hello, El Challen. Oh, thank you, everybody. Most kind of you. That is so nice. In 1967, so if we had to depend a lot on a lot of different variables of a star in order to understand what kind of black hole it would form after it has collapsed into one, then that could be a lot. Stars are very there's a lot of variety of stars. There's a lot going on in a star, but we will see what Stephen Hawking has to say about that. As far as when it does collapse into a black hole, what are the things that are sort of important to know? In 1967, however, the study of black holes was revolutionized by Werner Israel, a Canadian scientist. So his name is Israel, but apparently he's a Canadian scientist who was born in Berlin, brought up in South Africa, and took his doctoral degree in Ireland. What a global personality. So his name is Israel. He was born in Berlin, brought up in South Africa. How amazing. And took his doctoral degree in Ireland. Israel showed that according to general relativity, non-rotating black holes must be very simple. They were perfectly spherical. Their size depended only on their mass, and any two such black holes with the same mass were identical. So even though stars may have a lot of complexity, complication, etc., black holes that come from those stars, like once the star has collapsed and done its thing to become a black hole, basically it has died, to then give you a stellar remnant, which is in this case a black hole, again depending on the initial mass of the star, then that black hole is actually more simple than one might think. It pretty much kind of just depends on the mass, and if it's especially a non-rotating black hole, then it's very simple. It's very simple, perfectly spherical, and the size depends only on the mass. And any two such black holes, doesn't matter which stars they come from, any two such black holes with the same mass were basically identical. They could, in fact, according to this, they could, in fact, be described by a particular solution of Einstein's equations that had been known since 1917. So this is the year 1917 that I was recalling when we were talking about LIGO as well. I believe, so 1917 was an important year for general theory of relativity. And then 100 years later, around 2017 is when LIGO came out with its measurements. So it's really quite cool. Einstein was, of course, very ahead of his time in that sense that he made theoretical predictions with his theories about gravitation that weren't quite experimentally directly observed and measured until 100 years later. So wish he was here for that, but you know how death works, how people sometimes die. So anyways, they could in fact be described by a particular solution of Einstein's equations that had been known since 1917, found by Carl Schwarz.